Welcome to this Radmat CPD presentation on inverted roofing, a guide to design and specification. We have set 5 main learning aims for this CPD. They are to assist the specifier to understand inverted roof construction, identify the features and benefits of inverted roof construction, know the key design considerations, comply with regulations and codes of practice, and be able to evaluate the suitability of product and specifications for inverted roofs. To achieve these objectives, let's start with a bit of Roofing 101 and go through generic flat roof definitions so we proceed with a common understanding. A traditional cold roof has the insulation placed below the structural deck. This is very typical of timber roof construction, both flat and pitched roofs. This system relies on a vapor barrier beneath the insulation and incorporating a continuous flow of air to disperse water vapor within the structural void. The waterproofing membrane is exposed to thermal shock, UV degradation, and maintenance foot traffic. Due to limitations of design, this construction method is unable to meet current thermal regulations and, when this doesn't work effectively, water vapor can reach dew point and condense within the structure, causing damp and rot and potentially decreasing the efficiency of the insulation itself. A warm roof uses insulation above the structural deck. The waterproof covering is placed above the insulation and a vapor control layer is placed below the insulation. Unlike the cold roof, there is no risk of condensation occurring within the structure. However, the risk of condensation between the vapor control layer and the membrane must be calculated in accordance with BS 5250/2011 Code of Practice for Control of Condensation in Buildings. Like the cold roof, this system leaves the waterproof layer exposed to impact damage and the elements, because the membrane is laid above a high-performance insulant. Inevitably, the membrane is forced to act as a heat store, thermally stressing the membrane and contributing to the urban heat island effect in cities. This UV degradation by the sun creates high surface temperatures, causing the material to expand and then contract when temperatures drop. Over time, this puts strain on the waterproofing material and can cause irregularities in the surfaces and cracking. Ultimately, these factors will cause the failure of the roofing system, typically anywhere between 10 and 40 years into the future, depending on the waterproofing material. An inverted or protected roof is a form of warm roof construction in which the insulation is placed above the waterproof layer. Ballast, paving, or a green roof is then used to hold the insulation in place. In inverted roof construction, the waterproof layer also acts as a vapor barrier, eliminating the risk of condensation within the roof construction. This type of roof construction has the advantage of protecting the waterproof surface from impact damage and the elements, as well as insulating the structure. Its limitation in application tends to be the structural load of the system. Whether a ballasted roof, paved roof, or green roof, the upper layer protects the insulation and waterproofing membrane beneath, significantly reducing urban heat islands effects. This graph summarizes the thermal stability that putting the insulation above the waterproofing provides, a key component in achieving a BBA certified for the design life of the roof or structure in which it is incorporated. Minimizing the urban heat island effect in this way also makes a positive contribution to a city's and the world's climate. It additionally protects waterproofing from mechanical damage and effectively uses the waterproof layer as vapor control to control condensation risk. Now we have established the correct definition of an inverted roof, we will look at the main components used in the roof's construction before moving on to design and specification. Inverted roofing is typically installed on a concrete deck due to the 80 kg per square meter loading required to retain the insulation on the roof. In situ concrete is the easiest to apply to, ideally without a screed to falls, as this can complicate the application and delay the installation program. But how do we achieve the falls without a screed? Later in the presentation, we will demonstrate why you can install an inverted roof to zero falls and satisfy all relevant construction standards. Precast concrete can also be used, with or without a screed, but the installation method will alter slightly as you have to consider the panel gaps if not using a screed. Glue laminated timber, GLT, is also used on occasion. Whatever deck you have, it's important that the substrate is correctly prepared by the main contractor, which is why we have produced this guidance document for specifiers and contractors. Next in the construction comes the waterproofing membrane, and we will look at the main generic types used in inverted roof construction. Traditionally, mastic asphalt and reinforced bitumen membranes were used for inverted roof waterproofing. Today, mastic asphalt has more or less been replaced by hot melt monolithic membranes, which we will look at last. Reinforced bitumen membranes, or RBMs, are still used today, but due to the complexity to detail and time taken to install, they are rarely used by suppliers with better alternative product offers. The exception to this are single-layer systems based on POCB-modified bitumens, which can offer advantages when doing a refurbishment or working on small roof areas with minimal penetrations. Thickness range 6 to 8 mm. Increased resistance to damage by following trades. Can be loose-laid or fully bonded to primed substrate. Hot works, torching can be an issue. Slow to detail. Multiple layers can make detailing difficult. BBA durability typically 10 to 35 years. Single-ply membranes are mostly used in warm roof applications, which is probably where many of you have used them. Suppliers of these products will also specify them in inverted roof applications, especially when it is the only product type they offer. When considering a single-ply membrane for inverted roofing, check the thickness specified and the puncture resistance offered by that thickness or product. The membrane will be trafficked during installation, and it's important to avoid damage for obvious reasons. No single-ply is currently certified for zero falls application, so will require a screed to falls to comply with building regulations. This adds costs and prolongs the program. For codes of best practice, refer to the Single Ply Roofing Association SPRA Design Guide. Most commonly used in refurbishment applications, cold liquid applied membranes. Many are also suitable for inverted roof application, but as with single-ply membranes, puncture resistance for the applied thickness should be checked. Similarly, BBA certification for zero falls application should be checked, as there are many different types of liquid applied membrane, and it doesn't follow that because one generic type is approved for one manufacturer, it is automatically certified for another. Many different types can be difficult to compare apples with apples. Thickness range 1.2 to 4 mm. Reduced resistance to damage by following trades. Typically fully bonded to primed substrate, preventing water tracking if punctured. Typically two-coat application, requires less skill and experience than single-ply. Weather and temperature dependent installation. Quick to detail with. Accommodates high volumes of penetrations easily. Easy to install on small roof areas. BBA durability typically 20 to 35 years. For codes of best practice, refer to the Liquid Roofing and Waterproofing Association, LRWA, Liquid Applied Code of Best Practice. Hot melt monolithic membranes are the most commonly used types of waterproofing used for inverted roofs. Since the mid-1990s, they have taken over the market from traditional mastic asphalt thanks to their easier installation and greater flexibility. There are a number of manufacturers, and when comparing the product offers, do check the product complies with the Liquid Roofing and Waterproofing Association (LRWA) Hot Melt Code of Best Practice. Some products marked as hot melt do not comply with this code, being installed as a single layer rather than two 3 mm thick layers. Few different types, but beware imitations. Thickness range 8 to 10 mm. Minimal risk of damage by following trades. Fully bonded to primed substrate, preventing water tracking if punctured. Two-coat application, simple to apply. Not weather temperature dependent, work continues in bad weather. Requires heating to apply. Air-jacketed melter needs to be near application area. Simple, robust details. Accommodates high volumes of penetrations easily. BBA durability, life of the building. These features and benefits show why hot melt monolithic waterproofing is typically the specifier's preferred choice. From here on, the presentation will focus on hot melt monolithic waterproofing for these reasons. Hot melt monolithic membranes are supplied in blocks of typically 16 kilograms in weight. These blocks are melted in an agitating air-jacketed melter, which come in different types and sizes. The key is to have an agitating melter, as this keeps the component parts of the hot melt mixed together throughout the installation. When installing hot melt, the melters create the main health and safety concerns. They typically use propane gas to heat the air that melts the blocks. It's all self-contained, but requires covering by a suitable method statement. Radmat have recently developed an electrically heated melter which covers these considerations, but this creates other method statement requirements related to the power levels required. The final health and safety consideration is the application of the molten hot melt, which is applied at between 180 and 210 degrees C. Again, a comprehensive method statement and suitable PPE are required. Later, we'll look at detailing and standards. Now, let's look at the insulation board options. These are the requirements for an inverted roof insulation board. They are specific to the application and rule out the types of insulation typically used in warm roof construction. The table shows the two main generic types of insulation available: extruded polystyrene and expanded polystyrene, and their suitability for specific applications in accordance with ETAG 0311, the European standard applicable to the insulation in inverted roofing. Expanded polystyrene insulation, EPS, should be manufactured to BS-EN 13163, Thermal Insulation Products for Buildings, factory-made expanded polystyrene products. It was introduced post the millennium after the development of a special grade of polystyrene bead that doesn't absorb water. Supplier product checklist. Is BBA for inverted roof applications? Not all are. Is BBA for green roof or roof garden applications? Not all are. Is it fire retarded? Not all are, and generally the employer's requirements will require the board to be non-flammable when stored. What are GWP and ODP? Thermal calculation checklist. Is declared lambda value as per BBA? Is moisture conversion factor used as required by ETAG 031? Has rainwater cooling factor been used as required by ETAG 031? The traditional choice for inverted roof systems worldwide, extruded polystyrene, is available from a number of manufacturers. The same checklist applies as for the expanded polystyrene. It is also worth noting that some boards are grey in colour due to the incorporation of graphite to improve thermal performance, which also aids identification. Vacuum insulated panels, VIPs, offer high performance for a given thickness. The downside is its greater cost per square metre and the need to prevent damage that may break the vacuum. This second point is easily overcome through education of the contractor and generally helps ensure that the roof area is respected rather than abused. The cost becomes less of an issue when the height benefits are designed into the structure. Above 20 floors, it may be possible to gain an extra floor, and on most projects, its use on small areas only have minimal impact on overall roofing cost. Most beneficial is the ability to comply with the thermal requirements of Building Regulations Part L, the access requirements of Building Regulation Part M, and the drainage requirements of NHBC Chapter 7.1. Since the publication of ETAG 031 in 2010, insulation technology continues to evolve. Some manufacturers of extruded polystyrene insulation have introduced technology to improve the lambda value of their boards to 0.034 watts per meter Kelvin, enabling a 205 mm thick board to achieve a 0.15 U value. Other manufacturers have invested in vacuum insulated panel (VIP) technology, enabling a 40 mm thick board to achieve a 0.15 U value. The decision as to which type of board to use will come down to available heights, costs, and fire performance. More on this later. The final key component in the evolution of inverted roof systems has been the addition of the thermal sheet or water control layer. This rolled material, typically manufactured from spun-bonded polyethylene, is loose-laid over the insulation board with 300 mm overlaps. It provides the means by which 90% plus of incident rainfall is drained from the roof. Key to effectiveness in use is the detailing, more of which later. Having moved into design considerations, now would be a good time to address what can often be the elephant in the room, namely whether or not you can design and install a roof to zero falls. BS 6229/2003 is the document that the building regulations refer to when it comes to falls on flat roofs, and BS 6229 specifies minimum finished falls of 1 in 80 achieved by designing to 1 in 40. But 2003 was a long time ago, and in 2016 BS 6229 will be updated to include zero falls applications as defined by the British Board of Agreement in Building Bulletin 4. Building Bulletin 4 is basically a précis of the requirements of ETAG 031, the European standard we talked about earlier when discussing insulation. So not only have Europe recognized that zero falls construction is acceptable, the BBA have produced a simple guidance and will certify products for zero falls application. In turn, the NHBC have recognized zero falls construction being acceptable in their Chapter 7.1 standards publication, which was updated in November 2015. You will also find reference to the zero falls application in the LRWA Hot Melt Code of Practice and the GROW Green Roof Code. When checking the suitability of a roof for zero falls application, it is important to ensure the manufacturer assesses the deflection plan for the deck to identify any low points that are not near rainwater outlets. If the outlets cannot be moved to areas of high deflection, the options of increasing ballast, paving or green roof loading locally to disperse the water can be considered. Another option is to use a vacuum-insulated panel to create internal gutters in the inverted roof insulation. We will now move on to looking at some common detailing, starting with threshold details. Here, the requirements to comply with Building Regulations Part L, Building Regulations Part M and NHBC Chapter 7.1 can cause design and construction issues when putting balconies over heated space. Typically, the key conflict is the thickness of EPS or XPS insulation required to meet Part L, impacting on the level threshold required by Part M and/or the drainage zone required by Chapter 7.1. In these circumstances, the introduction of vacuum-insulated panels has proven to be the only solution that avoids the condensation issues insulating in ceiling void creates. Detailing at parapet walls is straightforward, with the upstands being installed first, overlapping onto the deck. The flat area is then installed to overlap the horizontal element of the wall flashing. Once the hot melt is installed, an access protection sheet is installed to prevent the operative and the insulation sticking to the hot melt. Where the upstand is formed from a dissimilar material to the deck, such as timber or a metal section, an uncured neoprene strap is installed before the upstand is waterproofed. This UN strap accommodates differential movement between the dissimilar materials. The vertical board insulates the wall and has a cementitious face for aesthetics and robustness. At rainwater outlets, UN strap is again used to accommodate the dissimilar materials. Here you can also see the thermal sheet above the insulation being taken down into the outlet to ensure effective drainage. We have already looked at the potential conflict threshold details create. Here we are looking at a typical internal upstand beneath the cladding system. In this application, the hot melt waterproofing should extend a minimum of 150 mm above the finished roof level, in this case the top of the gravel ballast and paving. Again, if the upstand and deck are dissimilar materials, a UN strap will be used to accommodate differential movement. Where there is a small or unusually shaped penetration in the roof, hot melt comes into its own for ease of detailing. A galvanized steel curb is formed around the penetration, as shown here on a glass balustrade bracket. UN strap is then put around the entire curb, and the resulting box is simply filled with hot melt prior to installation of the access protection sheet. We have now completed our overview of inverted roofing systems. Before we review the learning aims, let's review the environmental profile of an inverted roofing system. Starting with the Green Guide to Specification. Most of the inverted roof insulation boards have an A or A+ rating, and as the insulant and deck type have the biggest impact on a Green Guide rating, these will drive the achieved level. As generally an inverted roof is on a concrete deck, an inverted roof will achieve a C or D rating. The Green Guide feeds BREEAM ratings, and here the biggest additional contribution will be the ISO 14001 certification for the manufacturing of waterproofing and the insulation. Over the past few years, the BRE have linked their BES 6001 Responsible Sourcing of Construction Products assessment to BREEAM. Currently, no roofing system manufacturer has spent the money to get a BES 6001 rating. It remains the domain of glass, brick and steel suppliers. Lastly, our hot melt monolithic waterproofing, its accessory components and Protherm insulation was chosen to supply Google at their new London office building, following a thorough assessment of the product's environmental profiles. That completes this Radmat CPD presentation, giving you an understanding of inverted roof construction, showing you the key features and benefits, a grasp of key design considerations, the relevant regulations and codes of practice, plus the knowledge to evaluate the suitability of product and specifications for inverted roof construction. You can now take the CPD quiz.